This is Brenda Wingard-Haynes, and this is Biochem 208, and this is our third flipped video on Unit 6. The last segment, we talked about naming enzymes. Now, on the next page of your lecture notes, we want to show you some actual reactions, and I pre-filled a little bit of this in for expediency. All right, so this molecule we should recognize as ethanol, and this one we should recognize as ethanal. Now, you know from prior units that when we go from an alcohol to an aldehyde, that is showing oxidation, which means that we are going to need an enzyme that is capable of oxidizing. And so the enzyme we're going to use is alcohol dehydrogenase, meaning that alcohol is our substrate. Now we know that if we have oxidation, that means we're going to have to couple to something that's going to show reduction. And in fact, we are going to couple this to a substance called NAD+, and we're going to get NADH plus H+. So the hydrogens that we remove from here are going to end up on the NAD molecule and H+. So a couple things here. If we know the carbon compound has been oxidized, then we know NAD+ to NADH plus H+ has to show reduction. Okay, so this is showing reduction. We are going to see this particular reduction half reaction over and over and over again in metabolism. So you're going to want to get comfortable with seeing that. Okay. The other thing we want to notice here is that when we have H+, here's a source of H+. So when we think about H+ building up, we should think that pH would have to go down, which means that we have to figure out some way of dealing with these hydrogen ions. And we have looked already at buffers. And buffers help us mitigate protons. All right? The other role of the H+ is TBA, and we're going to talk about them in the next unit when we talk about metabolism. All right, on our next example, we have a kinase, and kinases, remember, transfer phosphates. So I've put this one in a circle and this one in a triangle to show you that this phosphate is going to go somewhere. And the question is, what enzyme will we need and where is that phosphate going to go? Well, this molecule is called 1,3-bisphosphoglycerate. So my enzyme here that I'm going to need is going to be called phosphoglycerate kinase. And I'm going to have to couple that to ADP plus the phosphate that comes from here, and I'm going to make ATP. Now, what I know about this is that when I have ADP plus the phosphate to form ATP, I know that I'm going to have to add 7.3 kcal per mole. And that 7.3 kcal per mole that I put into that means that this is endothermic or endergonic. I'm going to call it endothermic, which means this reaction has to yield energy. It's going to have to yield at least 7.3 kcal per mole. Otherwise, there's no point in that reaction going forward. On the next one, this is an isomerase. And I'm going to tell you, you guys can hear my dogs in the background. They're not dog fighting, they're just playing, so I'm going to ignore them. This reaction needs an enzyme called malleate isomerase. So if I asked you what is the name of this molecule here, it wouldn't take a leap of faith to say that this is malleate. Now the other thing we want to notice here is that this molecule is cis, whereas this molecule is trans. So it makes sense that we would need an isomerase for this. And this molecule is now called fumarate. Now notice that this is not coupled to ADP to ATP or backwards, and it's not coupled to anything that would indicate redox. So that would infer on this reaction that in our reaction coordinate, our delta H overall is negative, and therefore the reaction is spontaneous on its own. All right, last but not least, and then I'm going to go take care of my darling animals. All right, this molecule that you see is pyruvate, and you're adding a CO2 to it to create oxaloacetate. So that would tell you that you probably need a carboxylase for this. And if I asked you what is the name of this enzyme, it wouldn't take too big of a leap of faith to guess that it would be pyruvate carboxylase. And you would be absolutely correct. This is pyruvate carboxylase, is the enzyme needed to add that carbon dioxide to the 3-carbon pyruvate. Now the other thing about this one is this one requires coupling to ATP to ADP plus inorganic phosphate, which we saw on the other page is going to yield 7.3 kcals per mole. And what that means then is that this reaction is going to require some energy put into it in order to drive it forward, and that it would have to be less than or equal to 7.3 kcals per mole. Otherwise, there wouldn't be enough energy to drive this forward. All right, now what we're going to see is we're going to see a lot of these enzymes moving forward, and you're going to want to get comfortable with the idea of the names, because once you get a handle on the names and how they're coupled, then we come back and ask ourselves, how do these enzymes work? And that's where we'll pick up on the next segment.